So we are starting our unit on functions. A lot of this unit is Algebra 2 review, actually. So it is a lot of information condensed together, and I am asking you to remember a lot, but hopefully you guys in advanced pre-cal do remember a lot from last year. All right, so first thing we're going to go over is how to determine from a graph if a line is a function. Who remembers how do we determine if something is a function or not? Yes. Is that vi? V? Vi? I'm going to assume vi, unless you tell me. Yes, the vertical line test. Vi? V. I was right the second time. V. Okay. So, you have to perform the vertical line test, which is where you take your pen or pencil and hold it vertically and pass it along the blue line, your graph. And if your pen or pencil touches the blue line in more than one place, it is not a function. So, is A, that quadratic, a function or not? It is a function. Thank you, Anna. Yes, you never touch that blue line in more than one spot. What about B? Is part B a function? Yes, again, that's a cubic function. You never touch it in more than one spot. Part C, what do you think? No, right? You're almost always touching that in more than one spot. Two spots, actually, each time. So no, it's not a function. What about part D? Yes, everyone's getting the feel of this. Wonderful. You did this a lot in Algebra 1. Of course, I know that was like 2 or 3 years ago, but... Next portion. Now, here we have a graph that does have x values dealing with pi, which don't get super scared because, oh my gosh, you see pi. It's just a number, right? 3.14. We will be dealing with pi a lot this year. Part A is kind of just reviewing function notation. Where are these notes? These notes are on our Schoology page. They are linked on that pre-cal content page on our main materials page. If you still can't find them after this, I can like share my screen and show you exactly where they are. So part A is reviewing function notation. Who remembers what variable the number inside of the parentheses after the function is referring to? I'm struggling to find the notes as well. Oh boy, should I pause? The notes are located like on the main page of our Schoology pre-cal under materials. If you scroll down to pre-calculus content outline, you look for today's date and you go over and it says unit 1.2 advanced function notes. The one that says print is the one I wanted you to print if you were willing to print. Okay, so the 0 in f of 0, what variable is that referring to? Yes, Caitlin, x. This 0 is referring to the x value. And then what is the entire function f of 0? What variable is that referring to? Y. Yes, y. So what this is asking is, when x is 0, what is the y value? Four. Yes, yes, good job, guys. So you look on the graph, you find the x value of 0 on the x-axis. 0 is right here. And you follow the graph up until you hit your blue line. Oh, look, when x is 0, y is 4. What about when x is 3 pi over 2? What is the y value then? Yes, good job, guys. Yes, it's 0. Right here, it's referring to this point. When x is 3 pi over 2, y is 0, or f of x, I should say, is 0. Then, when x is 3 pi, lastly, what is y, or f of x? Yes, Lewis, good. -4. It's this point right here. -4. Awesome. Good, good, good. Hopefully all this stuff is coming back to you. I know we didn't use function notation. We did use it in Algebra 2, but we didn't use it a whole lot. Mainly in pre-cal, we'll be using function notation. All right, now to review domain and range. Domain is the x values, range is the y values. Who wants to tell me in interval notation? Oh, thank you so much. I was going to do that. I was going to take time to insert the link, but I'm like, I don't have time right now. Thank you so much. I think it's Arnon. Thank you for doing that. In interval notation, does anyone know what the domain of this graph would be? Yes, exactly. Oh, and you had the correct brackets too. 0 to 4 pi. Why are we using brackets here and not parentheses?
Because it can be 0 and 4 pi.
Exactly. Yes, we have closed dots on the ends of our graph. Now, what if these had continued with arrows like this? What would the domain be then? In interval notation.
Parenthesis infinity to infinity.
Yes, -infinity to infinity. Perfect. Yes, but because we end on closed dots like that, that's why we use the brackets. All right, who wants to tell me the range? Remember, in interval notation, we always go from least to greatest. So what is our least y value here? Our least f of x. Yes, you got it. -4 to 4. So we look, okay, how far down the y-axis do we go? Well, we stop. Our graph stops right here at -4. And then what's our max value? We stop at 4. So in interval notation, we have -4 to 4. But other brackets. Yes, Shira. All right, list the intercepts. I'm not even going to bother to write these down, but I do want you to answer me. So what is the first, if we're reading left to right, what is the first x-intercept?
0. Oh, pi over 2.
Exactly, yes, pi over 2, Trinity, thank you. And I'm so glad that you gave me that in point form, because when we're talking about intercepts, it's a point on a graph. What about the second one? Wonderful, yes, 3 pi over 2, 0. That's this point right here. So we've done those two so far. What's the third one?
5 pi over 2.
Thank you. And it's okay if you talk over each other. It's fine. 5 pi over 2, 0. And then what's the last x-intercept?
7 pi over 2.
Beautiful, yes. It's like a in-class choral response. Wonderful. And then what is the only y-intercept?
0, 4.
Yes, good job. 0, 4. All right, so those, hopefully everyone remembers how to find x and y intercepts, especially when it's given right on the graph like this. Easy peasy points on a test if that's a question. How often does the line y = 2 intersect the graph? So here, ooh, were you going to answer? Go ahead. Yes. Yes, 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 yes. I was going to do a leading question asking, is y = 2 a horizontal line or a vertical line?
Horizontal.
Yes, it's horizontal. Yes, yes, yes. What it means is y is equal to 2 no matter what x is. So if x is pi over 2, it's 2. If x is 3 pi over 2, it's 2. If x is blah, 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 it's always 2. It's that line right there. So here, that y equals 2, you're right, does intercept 4 times. Which this, I mean, y equals 2, they actually, that's wrong notation. They're mixing notations. They should have said f of x is equal to 2 there. But that's being picky. They also should have put f of x here. These are all screwed up. For what values of x does f of x equal -4? Yes. You guys are, you're like, okay, she's going too slow. There are 2 of them. And what f of x is referring to, remember, is our y values. So we have 2. When our y value is -4, we have an x value of pi. And when our y value is again -4, we have a x value of 3 pi. Oh, my husky is being annoying. And then for what values, so this is the only maybe tricky one of all of this. Now, I mean, and we'll see. For what values of x is f of x bigger than 0? So what this is asking for is when is the graph of this function, when are the y values bigger than 0? Or in other words, when are they above the x-axis, right? So who knows how many sections of this graph are above the x-axis? I see why you're thinking 4, but not quite. Yes, Conrad and Tyler. There are 3 sections. 1, 2, and 3. Meaning that in our answer to this, we need to write it in interval notation is going to be easiest. And we need to encompass 3 separate sections, 3 separate intervals. So let's do one at a time. That first section I have circled in red. What would the interval notation be for that first section? Zero, 2 pi. Yes, or pi over 2. Yes, you're almost right. You're so close. It is a bracket because this top point is totally above the x-axis. So we want to include that 0. It is included in our interval. However, should this point be included in our interval? Yes, V. It should not be included in our interval. Does anyone want to unmute themselves and tell us why it shouldn't be?
It says greater than 0, not greater than or equal to 0.
Exactly. We only want the values of the line that are completely above the x-axis, not equal to the x-axis. If there had been a line here, then we would include pi over 2. But because there isn't a line under our inequality, we're not including it. We want all the values right up to it, but not on it. Okay. Also, does anyone know what symbol we put if there are multiple intervals? Yes, union, U. So I'm going to put a U. U for union. And then does someone want to give me the interval notation for that second interval? Second section. Is this too small for you guys? Is that better?
Is it 3 pi over 2 to 5 pi over 2?
Yes. Oh, and she put it in there. And should we have parentheses or brackets? Yes. Yes. Good job, guys. Again, we don't want to actually include those x values because they're on the x-axis. We want everything above it. So we put parentheses. 3 pi over 2, 2, 5 pi over 2. Now I kind of want to make a little comment here because I didn't realize until I taught my other advanced class that some people would struggle. Why do I not, or why did I not, I don't even know how they were thinking about this, but a lot of people wanted to separate the second section into 2 intervals. Why is that not necessary? Is anyone struggling with that, or should I just move on? Why do we not?
I mean, like separating to like the 3 pi to 3 pi over 2 to the 2 pi.
Yes,
2 pi
people were wanting
pi.
to do that. Yes, they were wanting to include that 2 pi in the interval somehow. Why is that not necessary?
Were they
getting confused with like y values because go left to right?
Exactly. They were thinking about least to greatest, the interval least to greatest, and they were automatically in their head thinking, oh, the greatest is 2 pi. But then you're confusing your x values and your y values. We're only talking about x values here. We're only talking about x values. So we don't need to include that 2 pi, even though it's the highest point on the graph. We're looking at our x values, and our least x value is 3 pi over 2, and our greatest x value for that section is 5 pi over 2. All right, and our last section, our third section. Someone want to give me the interval for that? Yes, and perfect notation too. We don't want to include 7 pi over 2, so we put a parenthesis. But we do include that last point, 4 pi, because it is completely above our x-axis. Any questions at all about this section of the notes?
I'm confused why you made a bracket over the 0 when it says greater than 0. Like, I still don't get that.
Okay. So again, I think this is the trickiest part about this problem is keeping track of your variables. So yes, it does say greater than 0, but remember, f of x in its entirety is referring to y. So it wants to know when y is bigger than 0, not x. So this 0 here is an x value. So if I'm saying bigger than 0, f of x is bigger than 0, f of x equals 0 is way down here. Is this point above that 0? Yes. So that's why we do a bracket there.
Okay,
Does that make sense? Okay. All right, any other questions there? Good question. How would you work if the graph extended onwards in both directions? You can't just list out all the possible intervals. You're right. We would never ask that of you. You're totally right. Like, you can't. I mean, you could. Nope, you can't. It's infinite, right? It's literally impossible. If it extended on forever with arrows, you would say infinite intervals. I don't know. We would never ask that. But good question. All right. Moving on to the next section. It says consider the function f of x is equal to x over x plus 1. This is a rational function. We had a whole unit on it, 2 units on it last year. And then it asks, is the point 1 comma 1/2 on the graph of f? Without using our calculator, how would we do this? Exactly. And what ideally would you end up with? 1/2. In order for this point to be on the graph of f of x, when we input 1, we would output 1/2. If it did not output 1/2, then it is not on the graph. So let's just go ahead and quickly do that. I'm going to input the x value of 1. And what does that simplify down to?
1/2.
Wonderful. Is that what we wanted?
Yes.
Yes. So what does that mean for us?
That's true.
It's true. The 0.1 comma 1/2 is on the graph of f. I'm not going to do part B because it's exactly the same as part A. Part C, however, says if f of x equal to 2, what is x? What is the difference here? What do we do differently? Yes. Instead of plugging in x, we're plugging in f of x, or the y value. So in my original function, I'm now going to put 2 where I saw an f of x and leave the x's alone. What do I do to solve this? What the heck? What? Oh. All right. So now it asks if f of x is equal to 2, what is x? Yes, record. Thank you. So what is different about this one? What should we do instead? Instead of inputting x, a value for x, what are we inputting instead? Yes, f of x is the notation for y. So instead of plugging in x, I'm going to plug in 2 in place of f of x. Now, and one class couldn't answer me on this, and I was like, what is going on? How do you solve this? What is your first step?
Multiply.
Yes, multiply both sides by the denominator to get rid of that fraction. Yes, remove the denominator. Perfect. One class for sure, an advanced class, no one was answering me. I don't know if they were just like zoning out or what. But here we go. You can also think of this, I know some teachers taught it as cross multiplying. This is the same thing as cross multiplying. Then what happens here on this right hand side? Yes, they cancel and you're left with just x. And then yes, I saw someone say distribute. Perfect. You distribute on the left hand side. So you end up with 2x plus 2 is equal to x. And then this is a linear line. Hopefully everyone in here can solve for linear. Okay. So is that my final answer? Ah, yes, I see people already putting it. Can't have the negative on the x. We change the sign of everything you can think of it as, or dividing by -1 or multiplying by -1. I don't care, as long as you get the negative off the x. And should I leave my answer like this? Why not? What do I need to do? No, I know you guys have been taught, oh, x needs to be on the left. It means the same thing. Yeah, you need to write it as an ordered pair. It asks for what point is on the graph of f. So you would write your x value you now know is -2, and your y value is 2. And then you're done. Any questions so far? All right. So now on to even, which I probably should have said beforehand. We're not going to finish these notes today. We're going to hopefully get to right there. So we're going to go over even and odd, then increasing, decreasing. Now I know you touched on even and odd a little bit in Algebra 2, but we're going to do much more with it this year. For example, we didn't tell you that, well, maybe your teachers did, but even functions, we can prove that they are algebraically even functions if f of -x is equal to f of x. If this holds true, if f of negative x is equal, it's the same thing as f of x, then yes, it's an even function. If instead f of negative x is equal to negative f of x, this means that this is an odd function. Now, we'll see how many brainiacs we have in here. What, without even me telling you, does this look like on a graph? Why? Ooh. Oh, someone already, Morris already answered. Jeepers. Oh yeah, you guys are all doing it. Okay. Exactly. Here on even functions, the only variable being negated is your x variable, meaning it's a reflection over the y-axis. So here you can write symmetric with respect to the y-axis. Whereas odd functions, notice both variables are negated. Both the x and the y have negations, meaning it's symmetric with respect to the origin. Yes, you're right. Wonderful. So what this means is if the point xy is on your graph, the point negative xy is also on your graph. If the point xy is on your graph, the point negative x negative y is also on your graph. So, and people already jumped ahead and answered me, but part A, is that an even, odd, or neither function? Even. Yeah. You see it's reflected, it's symmetric over the y-axis. Like if you were to fold over the y-axis, everything would line up. This is even. What about B? Yeah, you had that loaded in already. No. Oh, no. No, that's not right. Yeah. It's neither. It's neither. In order for it to be an odd function, it absolutely has to go through the origin. That's your very first checkpoint, okay? If it doesn't go through the origin, it can't possibly be odd. So this is neither. Now C. What about C? Yeah, this one is odd. Yes, it goes through the origin, and if I was to look, and I know that this graph isn't numbered at all, but say I said that this was 2 and this was 3, so this point is 2, 3. I look and I negate both of those, negative 2, negative 3. Is that about a point on this graph? Well, yes, it is. This is an odd function. Oh, why am I circling it when I didn't the other ones? Now, finding it, looking at a graph and knowing whether it's even or odd is very straightforward. But we will also ask you to look at a function and algebraically determine whether or not it's even or odd. And to do this, you have to look at these above definitions that I already showed you. Now, it is easiest to check for even functions. So I would try to check for even first, and then if it's not even, then you check odd. The reason it's easier for even is because, look, this is the original function, f of x. You're only having to compute or find one different function. Whereas odd functions, you're having to find 1, 2. So first, on this first problem, we have to figure out what f of negative x is equal to. So all that I have to do to figure out what f of negative x is wherever I see an x in that function, you replace it with a negative x. So that's what I end up with. Now, my last class period really struggled, actually. I think that they were just overthinking this. What can negative x cubed simplify to? Parenthesis negative x and parenthesis cubed. What can that simplify down to? Yeah, the parentheses can go away because you can think of this as cubing both the negative and the x. So negative cubed, negative 1 cubed, is negative 1. So this remains a negative, and the x is cubed. What about 5 times negative x? They also struggle with this. I think that they just got hung up. I don't know. Yeah, it's just negative 5x. So now if I'm checking to see if this is even, what am I looking for? I'm looking to see if this new function I just found is what? Yeah, for them to be equal. For what to be equal? This new function and also the original. Yes. So, are these two the same? Exactly. You guys got it. Are they the same? No. No, right? The bottom one we just found, f of negative x, has 2 negatives in it. That's not like the original. So this is not even. We now need to check for it being odd. Now, in our odd definition, we have to find both f of negative x, which, oh my gosh, we just found. All we now need to find is negative f of x. Which this means we're negating the entire original function. We're putting a negative out in front. And I just distribute the negative in, and it becomes negative x cubed minus f of x. So, is this an odd function? Whoops. Yeah, because these two functions, f of negative x and negative f of x, ended up with the exact same thing. So it is an odd function. If this had ended up like this, what would it have been? Neither, right. And Karina, to answer you, that's kind of what we told you to guesstimate in Algebra 2, but there's a little bit more to it than that. Yes, oh, we've got 2 minutes. Yes, if, say, you just had x cubed as your function, this is odd. Yes, if you just had x to the 4th, this is even, because it's an even number and an odd number. But when you have stuff after it, that's when it changes things up. It's not always considered even if the exponent is even. For example, if you had a quadratic who has been translated to the left 2, yeah, that's still a quadratic, but is it an even function? Is it reflected over the y-axis? No, this is neither. Does that make sense? All right, so this is what I did with my last class because the exact same thing happened. Either you can stay on the notes now or stay on the Google Meet, and I'm going to go over increasing, decreasing, and constant functions, or I can record this and upload it to our Schoology page and you can watch it later. I don't care what you do. I mean, I would prefer you stay on so I don't have to do a recording. Like all of my students stayed on last time, but it's totally up to you. I can't make you stay on, if that makes sense. So let me populate your Google form. And I'm throwing it in the chat now. This is what you click in order to be counted present. Click it, answer the questions, and submit. You just need to click it before I close out of this Google Meet, because once I close out of this Google Meet, that form is lost. All right, so you can open it. You don't have to answer it right now if you want to pay attention to the notes. Just open it and then come back to these if you want to pay attention. If not, you can leave and I'll see you on Thursday. All right, increasing, decreasing, and constant. These are intervals on the graph that are either increasing, decreasing, or constant. So as you can see, that this example graph kind of goes all over the place. So it actually has all three. When it's talking about increasing, decreasing, and constant, it's asking about whether or not the graph is going up, down, or remaining the same. Up, down, or remaining the same, just like it sounds, increasing, decreasing, constant. Now, if I'm talking about going up, going down, or remaining the same, that's referring to the y values. So the y values are changing there, right? What this is asking for is what x values give you those increasing, decreasing, or constant values. So anytime it's asking for increasing, decreasing, or constant, it's actually asking for the x values that output these increasing, decreasing, or constant sections of the graph. And we always read graphs going left to right, right? Least to greatest. So this is my starting point right here. Now, starting at that starting point, I'm reading left to right. Am I going up, down, or remaining the same? Down. You're decreasing, right? So our first interval is a decreasing interval. Now, if I ignore everything else about this graph and only am focusing on a single point, can you determine from a single point whether you're going up, down, or remaining the same? You cannot tell. A good way to think about this is time, right? If you're looking at a single snippet of time, can you tell at that exact time whether or not at the next time you're going to go up, down, or remain the same? No. So that being said, can I say at the point -6, 0, can I say I am decreasing at that point? So should it be included in our interval? I put -6 with a parenthesis, because at -6, I cannot say whether or not I'm decreasing. Always when you're doing increasing, decreasing, and constant functions, it's always just going to be parentheses, no brackets. No brackets. So -6, and then when do I stop going down? At what x value? Yes, good. I stop going down at the x value of -4. Now again, at that point, you can't determine if you're increasing, decreasing, or remaining constant. Also, I kind of think of these in between points as transition points, right? You're changing direction. You're actually, either way, you know for sure you're not decreasing, you're changing direction. So -4 is not included. Is there another section of this graph that is also decreasing? Yeah, right over here, right? From 3 to 6. So I have 3, 6. Is this my finalized answer? This is actually interval notation, right? How many intervals do I have? What goes between intervals? A U. Now on Math Excel, I believe that they're, I don't know, being lazy. They don't want you to write the U. They just want you to put the intervals with a comma between. Side note. All right, now increasing. Where on this graph am I increasing? Or going up? Exactly, yeah. Oh, nope. You're almost right. Yeah, the x value from this point to this point, you are increasing on this graph, and you only refer to the x values. So you're increasing from -4 to 0. Is there anywhere else on this graph that you are increasing? Will it count the answer wrong if you put the U? Yeah, unfortunately. But on your daily grades, you can keep redoing the problem infinitely, an infinite number of times, and you'll still get full points. Now, if you get the same problem wrong, I think it's 2 or 3 times, it'll make you do another problem. But still, you can keep doing problems until you get 100. And then constant, finally. What the heck? Constant. What is my constant interval? Most of the, yes, from 0 to 3, yes. Most of the Math Excels are daily grades, but we do our quiz on Math Excel, and we also do our test on Math Excel. So no, not all of them are daily grades. And on the quiz and test, no, you cannot redo problems. So, are there any questions on what we went over today?